Welcome students. Previous class we have discussed about diffraction of light, what is Snell's law and law of refraction, and also we have discussed the relation between refractive index with speed of light, and what is actual refractive index and what is apparent refractive index. And actual refractive index merely proportional to inverse of wavelength of light. Okay. So refractive index depends on the pair of medium and wavelength of light, and all. Okay. And apparent refractive index means refractive index of one medium with respect to another medium. Okay. And I told you that for apparent refractive, 1 mu2 means mu2 by mu1 equals to sin I by sin. So for easier to solve the numerical problem, we can use this relation that mu1 sin I equals to mu2 sin R. Okay. Means mu of one medium means actual refractive index of one medium into sine of angle of that medium. Okay, equals to refractive index of another medium into sine of that angle of incidence or angle of refraction of that medium. Okay, and we did some problem also. So today, and also I told that for refraction through rectangular glass block, the incident ray and emergent ray should be parallel, means I equals to E. Okay, so today we will see the lateral displacement due to refraction through parallel glass slab. Suppose this one is parallel glass slab. This one is parallel glass slab, and a ray, suppose PQ, is falling on one point P on glass slab, and if I draw a normal on it, let me draw it. So if I draw normal, then this one is the angle of incidence in air medium, and this one is R. Suppose angle of refraction, then this one should be R, because these two normal are parallel to each other. Okay, and this one is will be I. I told you that angle of incidence equals to angle of emergence. Okay, now we have to find out lateral displacement. Lateral displacement, if we remove the glass slab, then which direction the ray will go? This direction, right? Ray will follow the straight path, but by introducing this thin glass slab, the ray following this path. Okay, so that lateral displacement means this one is the, this value is the called lateral displacement. Okay, suppose a PQ is the incident ray, QR, suppose this point is R. Okay, then and this point is S. RS is the emergent ray. So here incident ray equals to PQ and emergent ray equals to RS. Okay, and suppose this point is T, then lateral displacement is RT. Okay, so we have to find out, or we have to know that this lateral displacement in which property, on which property this lateral displacement depends. Okay, so we can prove this one, but proof is not in your syllabus, but I will show you. Okay. If I join this one and suppose this one is R P S. Suppose this one M. Okay. And here you see here is a triangle Q, M and R. Okay. If T be the thickness of glass. Okay. And let me write thickness of glass slab equals to T. Okay. Then from triangle QMR. Okay. From triangle QMR, we can write that cos R equals to base by hypotenuse, means QM by hypotenuse means QR. Okay. And QM is the T thickness, QM by QR. Okay. Cos R. And another triangle from triangle QRT, this one. Okay. So from triangle QRT, if we want to write sine, tell me this, how much angle this one? This one will be I minus R, right? The total angle is I, so this angle will be I minus R. So sine I minus R, we can write height by hypotenuse means RT by QR. RT by QR. Okay. Suppose cos R equation is equation number 1 and sine I minus R equation number 2. Then if we write sine I minus R by cos R, then we will find out RT by QR and cos R means T by QR. So here into T and QR will be here. So QR square cut out, then RT by T. Then RT we can find out that RT means lateral displacement, which is equals to T sine I minus R by cos R. Okay. So lateral displacement on which property it depends on? We can find out that thickness of glass slab. So lateral displacement depends on, one is thickness of slab means glass slab, 2 angle of incidence, and R depends on refractive index. So third point will be refractive index of glass slab. Okay. On these three property, lateral displacement depends on. Okay. You have to know these three property. But if you can remember this proof. Okay. This one is called lateral displacement due to refraction through parallel glass slab. And there are multiple images in thick glass plane mirror. So if a ray fall on thick glass plane mirror, we know part of light will reflect and part of light will refract. I told you. So we get multiple images. So here there is important part, real and apparent depth. If we see something underwater, then we see we cannot see the actual position of this object. Suppose if you see a coin inside water, you will see that the depth of the coin is decreased. Means we are seeing that the apparent position, not the actual position of uh, coin. Like this, if you see a fish inside water, inside river or in pond, then you will see the apparent position of water. So if you aim to throw a stone to a fish, but the stone will not hit the fish because your aim is to the apparent position of fish, not the actual position of fish. Here you see this one is the actual position of fish, but you will see the position of fish is this point. So if you throw a stone to hit the fish, but the fish will not affected. Okay, because the in this position there is no fish is there. The position of fish is slightly lower than actual apparent position. Okay, that means the depth of fish, this one is called actual depth of fish. Okay, actual depth, and this one is called apparent depth. Okay, and there is a relation between them. Group is not in your syllabus. So apparent depth by actual depth equals to refractive index of I medium by refractive index of object medium. Okay, so here if your I is I in air, okay, here air written also, so then refractive index of air will be Ri of air will be, we know, 1 by refractive index of object medium, suppose mu w, mu water, then you can write mu w. Okay, then apparent depth will be depth, it can be denoted by d dash equals to actual depth d by mu, mu w or mu of medium, object medium. Okay, this one is object medium, and here we have taken that I in air medium. Okay, so d dash will be d by mu. So we know that mu should be greater than 1 for any object, any medium will should be the denser than air medium. Okay, so as any medium is denser than air medium, so d dash will be d by mu, means apparent depth should be less than the actual depth. Okay, and there is some phenomena in nature, so that there is early sunrise and delay sunset. Okay, so when at morning and at evening, when the sun is below the horizon, horizon means if we draw a tangent on the earth's surface, then this line is called horizon. Okay, when the sun is below horizon, then these are, in this picture you see that these are atmospheric layers. We know stratosphere, troposphere, atmosphere, and last one is magnetosphere. Okay, and beyond the atmosphere nothing there is vacuum. Okay, so when light coming from sun is enter into atmosphere, that means it is coming from rarer medium to denser medium, right? So it will bend towards the normal, and here horizon act as normal at this point. Okay, and also the density of air gradually increasing towards the earth surface, so the ray moving towards the earth, gradually bending towards the earth surface. Okay, like this. So you will see that the position of sun is this point. So ray is coming. Okay. So this one is the apparent position of sun, but actual position of sun is this point. Okay. That's why after sunset and before sunrise we can see the sun. Okay. These things written here you can study. Okay. Now like this apparent height also, that if your eye is inside a denser medium, suppose inside water, suppose a fish is here. Okay. A fish is here and the actual position of body is here. Okay. But fish will see that position of body is here. Means actual height of bird is that much, but fish will see that bird of height is more than actual height, age rest suppose. Okay. And there is a relation between them also, like this apparent height by actual height equals to refractive index of same eye medium by refractive index of object medium. Like depth, you see in depth also apparent by actual, eye by object, apparent by actual, eye by object, apparent by actual, eye by object. Like this here also apparent by actual, eye by object. Okay, same thing. So apparent height here means h dash by actual height h equals to refractive index of eye medium is mu, and suppose object is in air, then air medium you can say 1. Okay, so h dash will be mu h. So here as mu greater than 1, so h dash greater than h. So in case of pond, okay, so bird will see that fish is height of fish is decreased, means depth of fish is decreased. Okay, bird will see the position of fish is that this position. Okay, and fish will see that the position of bird is this position. Okay, so fish will see that bird is far away from it, and bird will see fish is nearer to it. Okay, everything is illusion, nothing is actual. Einstein told also that everything is relative, and here also everything, position and speed, everything is relative here. Okay, here also in this picture, so this girl will see that the position of this man is this position. Okay, this is an apparent position, and man will see that the position of girl is this position. The girl is here written also a scuba driver in pool, and this trainer, sorry, is driver, and this girl is trainer here. Okay, now let's do some problem. One problem is a glass block 3 semi thick is placed over stem. Okay, means one stem here, suppose this one is a stem. Okay, a glass block is placed on it. Okay, and thickness here written 3 centimeter. Okay, calculate the height through which image of the stem is raised. So how much height raised the image of stem, and refractive index of glass given 1.54. So mu given, mu equals to 1.54. Okay, so the actual position of this stem, this one is stem suppose, and the actual position of stem will be here. Okay, sorry, relative position. So the apparent position, apparent depth will be d dash this one, and actual depth is d. So here d is 3 centimeter, and apparent d dash will be, I told you, d by mu. Okay, as actual depth will be less than apparent depth. sorry, apparent depth is less than actual depth. So 3 by 1.54 centimeter. Okay. So here written, calculate the height through which image of the stem raised. So image of stem raised by, suppose d double dash equals to d minus d dash. Okay. So actual depth is 3 centimeter. Apparent depth is 3 by 1.54 centimeter. So height raised, this one is d double dash. So d double dash will be 3 minus 3 by 1.54 centimeter. Now this can be calculated. Okay. The next problem, the floor of water tank appear at depth 2.5 meter. Appears at depth. If the refractive index of water is 1.33, find the actual depth. So appears at depth means apparent. Okay. So here d dash is 2.5 meter and mu given 1.33. We have to find out d. Okay. And we know d dash equals to d by mu for depth. So here d dash is, so d will be mu d dash. So mu given 1.33 and d dash is 2.5 and it can be calculated. Okay. So that's all. Next class we will discuss about prism. Okay.